So here's our introduction to the array-based, I'm going to call it the slow find in action. All this is doing is, again, using the array that you and I talked about. And again, this is just the tree representation of it. So this will get more and more complicated as we add more numbers. And I'll show you examples of that here in a second. But the interesting part of the array implementation, it just uses an index number to basically tell us what set that the value that we're looking for is in. Now, it gets a little bit more interesting because you're going to end up with either negative numbers or positive integer values in this entire array set, and they have a meaning. If it's a negative number that is in that spot, that means that is the root of the set, and there may be other people connected to it. Whereas if it's a positive number, then we need to actually go to that node or that index to see if that is the roots, because again, you have other people that are relying on each other in a set. And again, I'll show you here example here in a second. So pretend that everybody is a brand new set here. So if I did a find on 5, the value inside of index 5, so this is not Quingy Dink, they're both exactly the same number, what I'm looking for, will give me a -1. Now, the -1 means that 5 is the root, but it's in its own set. So in actuality, I would return 5 because 5's in its own set by itself, and dang on it, that's the root of that set. So that's with a simple find. So let's take a look at a very simple merged union. So in this one right here, I have 2 and 5 that have been merged. Now be careful, the arrows are a little misleading when it comes to this because in reality, 2 is the root, and that's really actually why it's higher than 5, but notice the arrow looks like it's going in the wrong direction. And that's because 5 is being merged with 2. So 2's the root, and that's why 5 got merged into 2. So that's why 5 is pointing to 2, but also 5 is pointing to 2 actually in the array too. So here's index 5, I look at the value, says, hey, I'm merged with 2, so go check to see if the 2 is the root. So I'll jump over to the 2. Look at the value of 2, -1. So, okay, as soon as I know it's -1, I know 2 is the root. But notice it doesn't go backwards. There's no way for me to tell that 2 is actually linked to 5. There's no way of going backwards down the tree on this overall structure and data structure that we're using for disjointed sets. But it does, 5 tells you where to go next in its value. So again, it's of a positive value. You need to travel to that particular node. And then when you finally end up with a negative value, you know you're at the root of that tree. So here's another one that's a little bit larger with 15 and a whole bunch of things that are in there here, and we'll take a look at that. So here's the overall setup that we have here, is that we're going to merge this set that you see right here where my hand here is going, and it's being highlighted here, of 15, 14, and 1. Now notice the order, by the way, is that 15 was merged with 14, and then 14 was merged with 1. So 1 is going to be the head and root of this entire set. Now, if I do a find on 15 that I have right here, be careful of what the function's actually going to return, because it may not return what you expect. So first, I go to 15. And 15 tells me, hey, you need to go to 14 to get your answer of which set am I really in. So from 14, we go ahead and look at that and says, well, I'm actually with 1. I've merged with 1 in that order, by the way. So now we go down to 1, and 1 says, oh, I'm a -1, meaning that I am the root of this set, and that in this function of find of 15, it would actually return 1, because 1 is the root of that entire set. Same thing with 14. If we have this find 14, 14 would do these two steps right over again, and it would return 1 because its lead node or root node in that set is 1. Not -1, but 1. So that's where we have to be very, very careful about when we do a find in our disjointed set.